Hello, my name is Fanil. Me and my partner Sahil implemented a movie recommendation engine as our final project for the machine learning subject for the term fall 2016.
Recommender systems are found everywhere. They are found in almost every major social network. They are found in Netflix. They are found in Spotify. They are found in Pandora. What we wanted to do was to implement these systems, the two widely used systems, that is content-based and collaborative filtering, and be able to predict how a user will rate a movie given how others have rated that movie.
We used MovieLens dataset which has 5 CSV files, but we ended up using 2 CSV files, movie.csv and ratings.csv. In movies.csv, we have movie ID, movie name, and genres. And in rating.csv, we have user ID, movie ID, and the ratings that user will give to that movie. In content-based system, we recommend the items based on the user's preference. Thus, items matching user's profile or his preference to a particular genre or subcategories are predicted. In content-based system, we use unsupervised learning to implement movie cluster based on their genres. We used k-means clustering and k-modes clustering algorithm to build cluster. To build the cluster, we use k-modes for the categorical variables where we compute centers as a mode instead of the means.
After clustering the movies, we find out the highest mean rated cluster by our user for which the ratings are to be generated. After finding out the cluster, what we'll do is we will find out the top rated movies within that cluster by the remaining users. And let's say we find out 50 top rated movies within that cluster, we'll randomly recommend 10 movies from that 50 movies. To evaluate our clustering performance, we use two metrics. One is average within cluster sum of squares, which is the difference of a point within a cluster to its centroid, and the other is silhouette score, which basically is the difference between mean intra-cluster distance and mean near cluster distance for each sample. So in theory, higher the silhouette score, better the clustering performance, and lower the average within cluster sum of squares, better the clustering performance.
We can see from the below graph that we get 3 clusters for the k-mins and 4 clusters for the k-modes according to the max silhouette score, and we can clearly see that we found higher silhouette score and lower sum of square for k-modes, which signifies that we get better cluster performance for the k-modes than k-means.
Now we move on to collaborative filtering. There are essentially two types of collaborative filtering. One is item based, which is essentially saying customers who like this item also liked this item. And the other is user based collaborative filtering, which is saying that who are similar to you liked this item. So here we basically predict the user's ratings given how other users who are similar to that user have rated that item. In collaborative filtering, first we start out by creating a user item matrix where users are the rows and items are the columns. Items are basically the movies. And then we move on to compute the pairwise similarity matrix for each user if we are going to do user-based collaborative filtering, or each item if we are going to do item-based collaborative filtering. The formula to compute the ratings is this that is shown in the slide. What our algorithm does is to first compute the nearest neighbor of each user in the user item matrix, and then we cluster our user based on three algorithms. For k-means clustering, we use the Euclidean distance. For k-medias clustering, we can provide a distance metric, and we chose to cluster based on cosine distance. And for spectral clustering, it is a similarity-based clustering. This can help us to realize patterns that are not visible using k-means or k-mediates. So we used cosine similarity to compute spectral clustering. After forming the clusters, we computed the intersection between 100 nearest neighbors of a user and the users that lie within the same cluster. If the intersection is a null set, we simply retrieved the 40 closest user to a particular user. Then we predicted the ratings using the dot product between the similarity matrix and the rating matrix of the intersection. There might be some users who gener rates movies generally high, and some users may rate movies generally low. We combated that bias by subtracting the mean rating rated by a user and adding back that late rating after we have computed the dot product. Item-based collaborative filtering is analogous to user-based filtering. We simply take the transpose of our user item matrix and proceed with the steps that we followed for user-based filtering. We chose not to implement spectral clustering because spectral clustering should not be used when the number of rows to cluster is high, which is the case as we have higher number of movies than the number of users. We first divided our user item matrix into trained data and test data. We trained our model on trained data and we evaluated our performance using the test data. We chose root mean square error as our metric to determine our performance. We compared the performance of all five clustering methods, that is k-means user-based, k-mediates user-based, spectral user-based, k-means item-based, and k-mediates item-based. We can clearly see that k-mediates user-based is the best algorithm among the five algorithms. We can also see that the item-based clustering performs worse than simple collaborative filtering, whereas the user-based clustering performs better than the simple collaborative filtering. As you can see, the clusters for movies formed quite distinctly. We are able to identify similar movies and the clustering is of higher quality. On the other hand, the users cluster are not that pronounced. They are more scattered. But there's an interesting trend over here. We can spot one major cluster, that is the blue cluster, which may account that most of users like the same movies. So this may account for the pop culture phenomena in movies. One of the most difficult challenge to be faced that the movie IDs were not sequential. It means some movie IDs were missing from ratings.csv and movies.csv. So what we did was that we created a new ID that was sequential and we changed the corresponding ID in both the CSVs. Also, matrix multiplication is a costly process. It is a order of n cube process and we would have liked to optimize this using Spark. Also, we would like to look into SVD for our future implementation of recommendation system. And finally, we have all the components to build a hybrid system that can handle the initial phase, which we think will use content-based system, and as we get more users in our system, we'll be able to use collaborative filtering. That is for the future. To conclude, we found that the content-based system gravitates towards popular movies within a select few genres, whereas collaborative filtering is more personalized in recommendation. That is, the recommendations are more varied from different genres. Also, we were able to use nearest neighbors, TCA and clustering to develop a new algorithm that can do collaborative filtering and in fact reduced our RMSE up to 0.25, which is a huge margin. Although we would have liked to optimize the algorithm to be less in execution time, but we were able to achieve what we set out to do, that is reduce our RMSE score.